Hello everybody, my name is Ben Lunenberg and today I was speaking about keystone species, which is something I'm passionate about. My hope is that I can reach people outside the scientific community or anyone who is interested in learning about natural sciences. I have 4 objectives that I would like to accomplish in this presentation. For you to be able to define and identify keystone species, understand the role of keystone species, understand the 4 basic levels of an ecosystem hierarchy, and have confidence to speak about a scientific topic. Let's begin with a simple definition of keystone species. Keystone species are the single factor determining the stability of an ecosystem. An easy way to visualize this is to picture an archway. You can see that all the stones lead to a singular point. If this was damaged or missing, the entire archway would be weak or even collapse. This is exactly how keystone species function. They hold everything around them together, ensuring that there is a balance. This makes them one of, if not the most vital part of an ecosystem. With that being said, it is important not to be overwhelmed when seeing a definition. Try to tie it to something that makes sense in your head. Before I continue with keystone species, you should know the parts that make up an ecosystem and their importance. There are 4 basic levels, referred to as trophic levels, of organization in an ecosystem: producers, primary consumers, secondary consumers, and tertiary consumers. To visualize this, you can use a pyramid. This has been widely accepted because it represents necessary components like organism abundance and energy availability at each level. The producers are at the bottom of every ecosystem. They are the foundation that provides a start for other organisms. These species that are most abundant can generate their own food through photosynthesis and provide a large amount of energy for the next level. Examples of these include trees, shrubs, grass, algae, phytoplankton, and more. Primary consumers are herbivores that only forage for producers. They manage the growing patterns and species selection of the producers. This can be good and bad because the primary consumers will control certain species, but if there's too many of them, then producers won't be able to regrow, and environments will look more like lawns. With this, even after moving up one level, there is a loss in energy overall. Examples of primary consumers include rabbits, sheep, deer, and insects. Secondary consumers are comprised of carnivores and omnivores that prey on the levels below them. Without this trophic level, primary consumers would not be kept in check and the problems I discussed in the last slide would quickly occur. Even though there are fewer secondary consumers, they provide essential energy for the next level and are fluid, meaning a squirrel that eats nuts and fruits is considered a primary consumer, but once it starts eating insects and baby birds, that makes it a secondary consumer. Some examples would be coyotes, foxes, frogs, and snakes. Tertiary consumers are above all other levels. They manage both carnivores and herbivores, which gives them the most control over an ecosystem. However, this is the least abundant trophic level of the pyramid. There is little energy available for these species, but they are essential in creating a natural balance. Examples of tertiary consumers are wolves, hawks, eagles, and orcas. Now that you have an overview of ecosystem structures, we can get into the specifics of keystone species. Keystone species are the most valuable members of an ecosystem. They're able to maintain a natural balance between species, fill ecological roles that no other organisms would be able to, and are the key part in successful ecological restorations. Keystone species bring a variety of benefits to an ecosystem. As you can see, with keystone species, there's an increase in oxygen. The majority of oxygen production on Earth comes from keystone species. Biodiversity is enhanced from keystones promoting species diversity and function. They also greatly influence the management and purification of water. A healthy ecosystem with keystones has less soil erosion and more nutrient cycling. Keystone species are able to affect the climate by reducing GHGs, which are greenhouse gases like carbon dioxide and methane. Keystones can remove GHGs from the atmosphere and use them for energy and create better air quality. There are apparent harmful effects from the absence of keystone species. Oxygen production would significantly decrease, there would be a lower diversity of wildlife, and an increase in invasive species. Water would be unable to reach certain ecosystems and be filtered. The soil would be loose and become more acidic. Environments may not be able to adapt to the changing climate without keystones. The atmosphere would be susceptible to pollutants and become toxic. Now we can get into examples of keystone species. When covering the different trophic levels, I alluded to predators from the highest level having the most influence over an ecosystem. However, this is not always the case. There are 5 categories that identify different types of keystone species, the first being predators. Keystone predators are tertiary consumers. You'll have a rippling effect through the trophic levels from other predators down to plant species. This is known as a trophic cascade. If a keystone predator is removed, then the species from lower levels will get out of control. The most famous example of this is the reintroduction of wolves into Yellowstone. Without wolves predating on herbivores in Yellowstone, they continue to populate and overgraze the landscape, reducing many plant species. Prey are also keystone species by being the food source for predators. They are more resilient and less susceptible to becoming rare or extinct. From this list, snowshoe hares plays an essential role in providing food for the threatened Canada lynx. Ecosystem engineers are seen as keystone species. They alter the landscape around them, allowing nutrients to be accessible, which inherently influences the behavior of other organisms. For example, bison create habitats by trampling and eating certain plant species. Mutualists are two or more species that depend on each other. These species provide attributes that the other can benefit from. Without one, the other will soon go. Hummingbirds and bees both receive food from plants, and in return, other plants are fertilized from pollen stuck on them while feeding. Finally, plants provide food and shelter for other organisms. Woodland species such as oak and hickories benefit a multitude of species like insects, birds, spiders, mites, and even bears. Now we can steer away from the hard sciences and focus on why this is important to you. When we talk about nature, it sounds removed from our modern society. People aren't able to physically see it and therefore can't make the connection. But nature is all around us. It's in our homes, at work, at school. It doesn't take being a scientist to understand and appreciate the very center of everything in our lives. I'm not saying to go hiking or camping or whatever the hell silent walking is. I want you to feel that connection and not see science as a bunch of numbers and theories. After everything I've spoken about in this video, I want to leave you guys feeling like you can join a conversation about ecosystems or keystone species or climate change and have well-formulated opinions that matter to you. So be confident and go out there. Thank you for watching. Go ahead and check out these additional resources that I find incredibly helpful when sharing science with everyone. I will make sure to add links to all their channels in the description below.